How to find the optimal consumption bundle from the given utility function? The question is, given the utility function of a consumer is U is equal to Q1 times Q2. Q1 and Q2 are the two goods, and price of good 1 is 10 and price of good 2, that's Q2, is 2. Also the income of the consumer is $240. We have to find out the quantity of Q1 and Q2 which will yield the maximum utility to the consumer. Okay, so the question is pretty simple. We want to maximize the utility of the consumer, that is U is equal to Q1 times Q2, subject to the budget constraint. So budget constraint will be price of Q1 times units of Q1 consumed plus price of Q2 times units of Q2 consumed should be equal to the total income of the consumer, which is being denoted by B here. Let's write it here, B. Okay, now so we want to maximize this utility subject to the given budget constraint. Graphically, what exactly is meant by this? Let me draw a small graph here. Let us say we have Q1 on the horizontal axis, Q2 on the vertical axis with the given budget. Okay, let's draw the budget line here. So with the given budget line, consumer wants to reach to the highest possible indifference curve. Okay, so that is, let us say, so we have this with the given budget, consumer wants to reach to the highest possible utility. Okay, so highest possible utility will occur at a point where the budget line and the indifference curve have the same slope. Okay, it is a point where the indifference curve is tangent to the budget constant. This will be the utility maximizing bundle. Okay, because the slope and the slope of the budget line and the indifference curve are same here. So let us write this in specific form. P1 is 10, so we have 10 Q1 plus 2 Q2 is equal to 240. Okay, so we can do one thing to simplify it. Let us divide both sides by 2, so we will get 5 Q1 plus Q2 is equal to 120. Okay, so what will consumer try to do? So first order condition for utility maximization requires that the slope of the budget line, slope of the indifference curve, which is the marginal rate of substitution between the goods Q1 and Q2 should be equal to the slope of the budget line. Slope of the budget line is price of good 1 upon price of good 2. This condition must hold for tangency here. Okay, so MRS is simply the marginal utility of good 1 upon marginal utility of good 2, and it should be equal to the price ratio, that is 2 upon 10 here, 2 upon 10, because price of good 1 is 2, price of good 2 is 10. Let us, MU1 means the partial derivative of marginal utility of good 1 means the change in the utility due to the change in the consumption of good Q1, and similarly MU2 means the change in the utility due to the change in the consumption of good 2, and it should be equal to the price ratio, which is equal to 1 upon 5 here. Okay, so du upon dQ1 means the partial derivative of this function with respect to Q1, derivative of Q1 will be 1, so we are left with Q2. So Q2 in the denominator, we need to differentiate this again with respect to Q2. Derivative of Q2 is 1, so we are left with Q1, and it should be equal to 1 upon 5. Okay, let us solve it for Q1. So or Q2 will be equal to 1 upon 5 Q1. Okay, now we need to plug this value of Q2 into the budget constraint. Let us plug here the value of Q2. That implies 5 Q1 plus the Q2 is Q1 upon 5 should be equal to 120. Let us solve it further. So let me write it here. So this becomes 5 5 are 25, 25 Q1 plus Q1 is 26 Q1, 26 Q1 upon 5 is equal to 120, which implies Q1 will be equal to 120. Transposing it will get us reciprocated. It becomes 5 upon 26. Okay, let us do some. So what will we get here? I hope I am doing the calculation right. So we get here 13. So here we get 2 13s are this, and here we get 2 60s are. Okay, so we get 60 into 5 divided by 13. Okay, I hope I have done the calculation right here. So price of good one is 10. Okay, so the problem is here, price of good one is 10 and price of good 2 is 2. Okay, so we have 10 upon 2 here. So we have 10 upon 2, that means it becomes 5 here. So we have 10 upon 2 is 5. I was wondering why this came out to be in fractional form. Okay, so this came out to be Q2 derivative with respect to Q1, so we will get Q2 upon Q1 is equal to 5, which implies Q2 will be equal to 5 times Q1. Now we need to plug this value into the budget constraint here. So we will get 5 Q1 plus Q2 is 5 Q2, sorry 5 Q1, the value of Q2 should be equal to 120, which implies 10 Q1 is equal to 120, dividing both sides by 10, Q1 will be equal to 12. So consumer will consume 12 units of good Q1, and to find out the value of Q2, simply plug the value of Q1 here. We will get Q2 will be equal to 5 times Q1, so Q2 will be equal to 60. Okay, at optimal, consumer will consume 12 units of good Q1 and 60 units of good Q2. I hope I make myself clear in this video and you find out this video helpful. Thank you.